Good morning, students. Welcome to our science online class. My name is teacher Naomi, and today we are going to start our new topic, and it is all about forces and friction. Forces and friction. Okay. Forces and friction. Today we are going to learn about forces and friction. Without wasting our time, let's go direct. Now you see forces and friction. Students, what is force? What is force? What is force? Okay. Force is a pull or a push that causes an object to move faster or slower. It can make an object to stop or change direction. Okay, let me repeat. You read with me, student. Read with the teacher. Force is a pull or a push that causes an object. Object can be your bed, it can be your desk, it can be your chair, it can be a car, it can be what? Many objects. It can be a table. So it is a force that causes an object to move faster, very fast, to move slower, to move slow, and stop. No moving now, stop. Or it can make an object to change direction. If the object was going like this, it can change direction and start going like that because of force. And also it can make an object to change size. That is the definition of the word force. Force is a pull or a push that causes an object to move fast, slower, stop, change direction, or change size. This is the definition of the word force. Now, this is what we call that is this picture. This person here, I don't know whether it is a person or what. Let me add so that it can be somebody like okay. This person is pushing this object. This is an object, and this person is pushing this object. This object is going towards this direction. It is moving because of a force applied on it. The object is moving because there is someone here applying force. So, if you apply force on something, it moves. If there is no force that is being applied in something, there is no movement. Okay, students? If you apply force, an object must move, either fast or slow, or change direction. If you don't apply force on an object, there is no movement. The object will stand still. Very good. Now, let's continue. We have said force is a push or a pull. Okay, this is a push. And this is a pull. This one is pushing, you see, and this one is pulling something. Now, there is a difference between push and pull. When you push something, it goes away from you. And when you pull something, it comes closer to you, towards you, okay? When you pull, you are pulling towards you. And when you push, you are pushing away from you. Very good. Now, when we exert a push force on an object, when we exert a push, yeah, this is a push. This person here is pushing, pushing, pushing. Now, when we exert a push force on an object, it moves away from us. It moves away from us. Like this object here, this one is pushing, so this object will move away from this person here. The object will move away. And when we exert a pull force on an object, it moves towards you, Now you see this one is a pull, this object here will move towards that person because he is pulling it. This one will move away because he is pushing it. So when you push your friend will move away from you. And when you pull your friend will move closer to you or towards you. Very good. So up to there, students, I hope you have understood the meaning of the word pull and push. Okay, that is very good. I hope you are following. A force has a size. A force has a size. The heavier the object, the greater the force needed to move it. The heavier the object, the greater the force needed to move it. When something is very heavy, the opposite of heavy is light. No, students, I'm teaching you science at the same time English. So you listen to the vocabularies used here. Now, the area. Students, when something is heavy, this like A, then V, then Y, heavy. Opposite is light, not heavy. Something is not heavy, sorry, we say it is light. Heavy, light. Okay, this is the opposite. You know opposite of what? Opposite. O-P-P-O-S-I-T-E. Like opposite of small is big. Okay, now you know what opposite is. Now, the object, the heavier the object, the greater the force. The heavier the object, the greater the force. Right? This means when the object is so heavy, it means you need a lot of force to move it. When the object is light, not heavy, it means you need less force to move it. Very good. Now, example in this picture down here, this car and this car. So here we have car A and car B. Now, between A and B, who uses a lot of force to move this car? Between A and B, who will use a lot of force or more force to move this object or to move this car? If you understand that the area, the object, the greater the force, then you will be able to answer this question. A will use a lot of force, more force, and B will use less force. Okay, students, you understand? The area, the object, the greater the force. If the object is so heavy, so it means that you are going to use a lot of force to move that object, to push or to pull that object. When the object is light, like this one is so light because there is no loads, a lot of luggages, there are a lot of luggages here. Here there is no anything, here is nothing, meaning that this is lighter and this is heavy. So this is less force used here. This person here will use less force and this one will use more force. Okay, students, I hope you have understood why this one will need more force and this one will need less force. I hope you have understood. This one will need more force because there is a lot of weight here. This object is very heavy. This one will need less force because this object here is lighter. It is lighter, so less force is used. It is heavier, so much force is going to be needed. Very good. Next, what do we call a machine that is used to measure force? How do we call a machine that is used to measure force? And force is measured in which units? Which units? Like when we talk about centimeters, kilometers, and there is another one called meters. But how do we measure force and which units do we use? Force is measured by use of what we call a spring scale. Spring scale. Spring scale is a machine used to measure force. Spring scale is used to measure the size of a force. And force is measured in newtons. Newtons in short, N. So if you measure force and you find it is 10, so you are supposed to write 10 newtons. In short, you write 10 N. 10 N. This means that it is 10 newtons. This is how a spring scale looks like. This is a spring scale. This is a diagram of a spring scale. Spring scale looks like that. This is an apple here. So you can measure the weight. You can measure the force used to hold, to bring up an apple from down there. And when this one is being hung here there is a hook used to hang. So this spring scale will move downwards to show the force used to carry up an apple. Now, for example, here we have a spring balance held by hand. This is hand. And this is a spring balance. You hold it like this, you hold. And then this is a stone. Now, if you want to get the force used to hold this stone from down here, you just bring something like a paper pack, you put inside the stone and then you hang this hook up. Then you see how the spring scale will move. It will move down like this one and then it record here the total force used to clean up this stone. So as you can see, here is 5 newtons needed. 5 newtons. 5N. 5N in short, in full, is 5 newtons. So this one here is all about the machine used to measure force and units. The units of force. Someone will ask you, what are the units of force? Units. U, N, I, then T, then S. Like force is measured using which units? You say force is measured using newtons. Using newtons. N-E-W-T-O-N-S. Newtons here. Very good. It is good to know how to write these words. It is good to know how to write the words. Very good. So here, students, you should know that force is measured using spring scale, and force is measured in units called newtons. Very good. Next, students, let's see what a resultant force is. What is a resultant force, students? The resultant force is the total amount of force acting on an object or a body along with the direction of the body. The total amount of force acting on an object or on a body along with the direction of the body. We have not said that like opposite, no, along with. If you are acting your force from here, the direction of your object should move towards that direction. It should not move like opposite direction, along. So, we are going to see examples. We have a lot of examples to learn. The arrow, there is something we call the arrow in a force diagram, shows the direction of a force. The length of the arrow shows the size of the force. The length of the arrow, here students, what I mean, the length, what do we mean when we say that the length, why is that length here? This word here, length. The length of an arrow shows the size of the force. Now, students, I want you to look. I'm drawing an arrow here. This is an arrow. This is what we mean when we talk about arrow. So, the length means the arrow can be long or short. So the length of the arrow shows the size of the force. If the arrow is long, it means more force. And when the arrow is short, it means less force. Okay, students, have you understood about the concept of an arrow? When the arrow is long, it shows more force. When the arrow is short, it means less force. Okay, let's see. We can understand well with diagrams, you know. We can understand well with diagrams. Okay, let's see here. Examples of resultant forces. Look at this one. You see, it is a force acting along with an object. And the arrow can show the length of an arrow shows the size of force, whether it is more force or less force. Like when you look at this one, the two arrows, when you look at these two arrows here, this arrow and this one is too long and another one is short. This is 60 newtons and this is 30 newtons. This is why we say that the length of an arrow shows the size of force. Now this arrow here is too long and it is 60, meaning that this one here, if there are two, for example, let me say if there is Crystal here and there is Paige here, they are doing what? They are pulling this object. Crystal is using 60 newtons, is applying force which is equivalent to 60 newtons, and Paige is applying 30 newtons. Now, when you want to get the amount of force used to move this object here, you add 60 plus 30, and then you get it is 90 newtons. And this object will move towards the right. It will move towards the right. It will not move like this. No. Why? It can't move like this because there is no any force that is being acted from here. No force that is being acted from this direction. If the force is acted from this direction, then this object will move towards that direction. But because there is no force acted towards the left, we have only the two forces acting towards one direction, towards the right. So we add them together, 60 plus 30, and then you get it is 90. Then you get the total amount of force used to move this object. It is 90 newtons, and this object will move towards the right. Very good. I hope you are following, students. I hope you are following. And then we have another one here. So this one, the force was acting towards one direction. But here, two directions, both left and right. Left and right. So towards the right is 30 newtons. Towards the left is 10 newtons. Now, how do we get the force or applied on this object, and how do we get the direction in which this object will move? When you look at this, like someone is doing what? Pulling or pushing, is applying 30 newtons on this object. Another person is applying 10. If you look at this one, you will know that obvious. The one who is using 30 is using more force than the one who is using 10. So 30 is more and 10 is less. So obvious, this object will move towards the right. But you have to do calculations here. You have to take 30 and you take away 10. Then you get it is 20 newtons. So this object will use 20 newtons to be moved, and it will move towards the right, because towards the right has more force than towards the left. I hope you are following, students. I hope you have understood this one. This one is very easy, so easy. Just looking alone, if you look like this, you will know the answer automatic, because you follow the arrow. Like if the arrow is too long, it means that a lot of force is being used there. When the arrow is short, it means less force. Okay, let's see what follows next. Let's see what follows next. Okay, now this is and we might end up our lesson here, but let's see Look at these diagrams. Now these are boxes. Let's call them boxes. Now this is which way does the box move? Which way does the box move? Let's see. Now here we have 4 Newton to the left, 10 Newton to the right. Which way does the box move? Okay, students, the box will move to the left or right? Where? Is it left or right? Where does this box supposed to move to? Okay, very good. This box is supposed to move to the right because there is more force exerted towards the right than towards the left. So the box will move to where the force is much, and that is right. So this is the answer here, right. And here the box is this one, 10 newtons, 10 newtons. Both sides, the force acted on both sides is equal. To the left is 10 newtons and to the right is 10 newtons. Now what will happen to the box? What will happen to the box? Is the box going to move left or right or stand still? Can you think of it? Very good. This box is going to stand still. When the resultant force is equal, when the force is equal, when the force towards the left and towards the right are equal, we say that the resultant force is 0. The resultant force is 0. So the object is not going to move. It will stand still. Very good. Next, to the left is 10. To the right is 5. The box is moving to the left or to the right. Obvious, it is going to move towards to the right, where there is much force. Where there is much force. So, the resultant force is 10, is 5, solid is 5. How do we get 5? You take 10, you take away 5, and then you get 5. The resultant force is 5 Newton to the left. This box will move to the left. Very good. Next, the force to the left here is 15. 15. The force to the right is 5. The resultant force is 10 newtons to where? Of course, 10 newtons to the left, where the force is much. It is 10 newtons to the left. Very good. You take 15 and you take 5. You get 10. This box is being moved to the left using only 10 newtons. Next, here, the force to the right is this one, 25. You write here 25. 25. The force to the left is 15. The resultant force is 25 take away 15. You get 0, 10. The resultant force is 10 newtons to the left. Oh no, sorry, to the right. Very good. The right. So you take away 25. Take away 15, you get 10. So you get that the resultant force is 10 newtons to the right. And then the resultant force here is 0. 5. The resultant force here is 0. This means the box is accelerating. No. Accelerating is like moving in a high speed. And decelerating is like moving in a low speed. So this box is neither moving in a high speed nor in a low speed. So the box is moving at a constant speed because the force to the right and left is equal. Okay? And then the lastly, the resultant force is, you take 12, take away 5, you get it is 7 newtons. This means the box is moving to the left. Here, it is moving to the left. The resultant force is 7 newtons. This means the box is moving to the left. Very good. Okay, students, I want to leave you with a piece of work to do for me. Now, create your own example. You create your own example, and then next week, we are going to start from here. Each and every student is going to give us his or her own example. You can create it like this, like this, like this, or like this. It is up to you. So you create your own example, and then when we meet next, we will start from here. We will start from here. Okay, students? Okay, I don't want to go there. We will start from there next time. Is there any question, students? Is there any question? No question. Okay, I will end my lesson there. Thank you for watching and thank you for listening. See you again during our next lesson on next week on Tuesday. Thank you and goodbye.